In lesson 8.2, we talked about what it meant for two figures to be similar. So remember, to be similar, they had to have corresponding angles congruent, and the corresponding sides have to have equal ratios or the same ratio. So with today's lesson, we're going to actually prove two triangles are similar by some, you want to call them shortcuts, rather than knowing that in two triangles, you know, three pairs of corresponding angles are congruent and three pairs of corresponding sides have equal ratios. There's shorter ways to go about it. So that's what we're going to take a look at today. So remember, we're not proving triangles congruent. We are proving triangles similar. So the first way, the first option is using angle, angle, angle. So AAA. So this one states, if there exists a correspondence between the vertices of two triangles such that the three angles of one triangle are congruent to the corresponding angles of the other triangle, then the triangles are similar. So again, basically you have to have three pairs of angles congruent for this to work. Again, nothing about the sides, just all three angles. So in this example here, so we have angle A congruent to angle D, that's given, and angle B congruent to angle E, that's given as well. So because of that, our no choice theorem says that angle C would be congruent to angle F. Because again, if two angles of a triangle are congruent to two angles of another triangle, then the third pair of angles has to be congruent. So if I've got all three pairs of angles congruent, then I could state the triangles are similar by angle, angle, angle similarity. Okay? But actually, because if we know 2, the third pair is automatically, we can shorten that a little bit to just doing angle, angle. So angle, angle works just because of the fact that if you know 2 pairs are congruent, that third pair has to be congruent. So angle, angle states, if there exists a correspondence between the vertices of two triangles such that two angles of one triangle are congruent to the corresponding angles of the other, then the triangles are similar. So I'm just stating now that angle, angle is enough. You know, AAA works, but if you just want to do angle, angle, that is good enough because the third pair would have to be congruent. Now, there are other ways to prove triangles are similar besides just angle, angle, or angle, 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 okay? The next method is side, side, side. So this one basically is not talking about any angles. You're talking about all three pairs of corresponding sides being in the same ratio. So if there exists a correspondence between the vertices of two triangles such that the ratios of the measures of the corresponding sides are equal, then the triangles are similar. So in this one, you have to again know that all three pairs of corresponding sides have the same ratio. So in this picture, we would be given like the ratio of AB to DE is the same as, so here we go. So AB to DE would be in the same ratio as BC to EF, which again would be in the same ratio as AC to DF. So if that is true, then we can conclude that the two triangles are similar. So we've got angle, angle. Now we've got side, side, side similarity. And again, this is not proving triangles congruent. This is proving them similar. Okay. And then the last one we have is side, angle, side similarity. Okay. So this one you have two pairs of corresponding angles, or I'm sorry, two pairs of corresponding sides being in the same ratio, as well as the included angles being congruent. So again, if there exists a correspondence between the vertices of two triangles such that the ratio of the measures of two pairs of corresponding sides are equal, and the included angles are congruent, then the triangles are similar. So in this particular picture, what it looks like, again with highlighted parts here, so the ratio of AB to DE is the same as the ratio of BC to EF. So there's your two pairs of corresponding sides being in the same ratio. And we know that angle B is congruent to angle E. There's that included angle that's congruent. So again, because of that, you can state that your two triangles are similar. Okay, so as a quick recap, we have three methods, technically 4, but we use 3 for proving triangles are similar. We have angle, angle similarity. where you have two pairs of corresponding angles congruent. You have side angle side similarity, which we just went over, where you have two pairs of corresponding sides being in the same ratio and the pair of included angles being congruent. And then last but not least, we have side similarity, where you have all three pairs of corresponding sides being in the same ratio. Then again, the triangles are similar. So if we take a look at a few proofs to kind of get us going here. Okay, so on this next one, it says angle A is congruent to angle D, and angle 2 is congruent to angle 4, both given information. Okay, so angle A and angle D are congruent. That is one pair of congruent angles. But again, we need 2 to prove the triangles are similar. Notice 2 and 4 are exterior angles, so they're not going to directly help us. But if you look at the picture, 1 and 2 are supplementary, as well as 3 and 4. And the reason I want to make that connection is because 1 is an angle of the triangle and 3 is an angle of the other triangle. And my reason is if 2 angles form a straight angle, they are supplementary, or if the sum of 2 angles is a straight angle, they are supplementary. Okay, so since 2 and 4 are congruent, we can now state that 1 and 3 are congruent. And we haven't used this one in a while. But remember, if angles are supplementary to congruent angles, then they are congruent. So that is enough to prove the triangle similar, because again, notice we've got angles congruent here, and then 1 and 3 are my other pair. So again, if I've got two pairs of corresponding angles congruent, that is enough to state your two triangles are similar by angle-angle similarity. Okay, so moving on to the next one. So this time we know that TVPX is a trapezoid, and they told us the two bases. Now, think, why did they tell you the bases? Well, in a trapezoid, remember, your bases are parallel. So TV and XP are parallel. My reason, something like if a quadrilateral is a trapezoid, then the bases are parallel. You could say the bases are parallel in a trapezoid. That would be an acceptable reason as well. And remember, when you have parallel lines, you're going to have like alternate interior angles being congruent. So we can state that angle VTP and TPX are congruent. So again, remember your alternate interior angles make the Z. Okay, so again, this angle is congruent to that one. And if I look at the zigzag going the other way, going this way, we have another pair of alternate interior angles congruent. So TVX is congruent to VXP. Again, those are alternate interior angles, and they are congruent when you have parallel lines. So right there, I've got two pairs of congruent angles. So that is enough to prove the top triangle, TVY, is similar to the bottom triangle, PXY, and my reason is going to be, again, angle-angle similarity. Now, most of the time, your proofs are probably going to involve angle-angle similarity because you can have a little bit more variety. If you're going to do side similarity, they pretty much have to give you everything in the given. Okay, so if we take a look at the last proof, so we are given that MO to MP is equal to MS to MR. So again, given information. So there's my two pairs of corresponding sides being in the same ratio. So we still need something else, because again, that's a side and a side. So if you look at the picture, if I'm trying to prove triangle MOS and triangle MPR are similar, notice they have a shared angle at angle M. So I could state angle M is congruent to angle M by reflexive, and that should give me the two triangles are similar by side angle side. So again, we got my angle congruent, M is in both triangles, and again from the given, MO goes with MP, and that is the same ratio as MS to MR. So there's my side angle side similarity. Okay, so for today, your assignment is on page 342. You're doing numbers 3, 4, 6, 8 through 10, 12, 16, 18, and 19. Have a great day.